This is our continuing training series on Midas Gen. Today we'll be looking over a RC building. We're going to do an analysis and design of the following building you see on your screen. So we're going to go through the process of the modeling, and in addition to that, not just in the program, but we're going to be importing CAD files. And then we're going to go through the process of designing some columns and some footings for this model. And in the end, actually, we'll also go back and modify the structure and add some piles to it and some soil springs. So we'll kind of go through a few different like analysis processes and show some of the versatility of the program. So what you see on your screen are the dimensions of the model. So as you can see, it's a bit of an irregular structure, and also has some geometries like we can see here. This corresponds to what would be like a balcony of a hotel in some respects. And just as a side note, when I do apply the floor loads and define the floor loads, I'm actually going to switch the units to kips. But basically, these are the dimensions of the structure. We have around 11-story building. So we're going to be working with the following material in the following sections. Now we'll be using concrete, which you can define in the program by selecting standards and then select them from the database, or you can manually define it as well, whichever concrete. If you can't find it, you can just manually type in some of these values. And then here are the sections themselves. We're going to have 4 sections. So it'll be pretty straightforward. I'll go into the model and the program and show you how to define these sections. But we'll have some columns, some beams, a different section for a balcony beam, and then the piles, which will be, again, added at the end. And lastly, we'll also have a wall element. But from here on out, I'm actually just going to go ahead and open the program. This is a PDF that we will include in the upload in our page, so that if you want to try it, you can you can watch the video. We're recording it, and you can download the material and try it on your own. But from here on out, basically, I'm just going to follow these steps, but directly in the program. So this is Midas Gen. This is the interface of Midas Gen. We see we have like the review menu, which basically all the commands are by icon. It's not drop-down menus. And then we have the work stream, which of course has nothing yet because we haven't done anything. And then we have like message window and other kind of commands. So the first thing we want to do is go to our properties tab and just start defining material in the sections. And then from there we'll import the geometries straight from AutoCAD and just assign sections. So we'll go through that process. But in essence, in Midas Gen, you can actually even do the whole geometry in AutoCAD and just import the lines by layers. And as you're importing them, it's very easy to just assign the correct section to each layer, like columns or beams or such, as you will be seeing. So we go to material first, and we go to add, just to create the, in this case, only material we're going to use. But you can actually mix it up. Your structure can be steel beams and concrete columns. It doesn't really matter. You can have a mixed structure, or even, steel reinforced concrete, or as I mentioned, user defined. So, but for this tutorial, still being part of our initial tutorials, very basic introductory, let's just keep it for what would be just concrete. And then we go to the next tab, section tab, and we're going to add the 4 sections that we had seen in the table. So we see here we have general sections, and then when you select one individually, then you can either user define the dimensions, or you can try to find, depending on the, for rectangle, it's not going to be in a database, but if you had other sections like an I section, then there would be a substantial database you can choose from for your section itself with the dimensions already predefined. But like I said, in this case, we're only going to do, just for simplicity, for keeping as an introductory tutorial, keep it as a solid rectangle, and for the piles, it'll be solid round. So I'll just go here to user, and I'll define the first three sections. So we have the column, which we had said was a 2x2. Here you can change the offsets in case you were diligent about, or you wanted to modify that on your own. This is where you can change it. So when you define the section. So I have my program for autosave. So here it's just prompting me to save the file, to go ahead and save the file so that nothing is lost. You can also define the autosave to be, I think I have it every 10 minutes. So I'll just save it into a folder so it doesn't keep prompting me over and over. It'll just, from now on, automatically save it. So we have the column. So I'm going to go to apply. And then applying, we see now there's a new section here created, and the identity has changed to 2. So I can just keep this window open and then go to the next, which would be the beams. And this one is the beam is 1x1. And again, if I want to change the offset, there's a option down here. So you just have to kind of keep track of those locations if you really want it to be meticulous, but you can actually also visualize it in the final model and then go back and just modify. You can always go back and change the offsets even after you finish the model. So we have the beam, then we have the balcony beam, which will be a 1.5x1. Apply. And then the last one is the pile. So I'll go to solid round pile. And this is a 2-foot diameter pile. So we have our 4 sections created, and the last thing I want is just the wall, which has a thickness of 1.5. And we'll just do the in plane and out of plane. But you can also here define information about specific, I guess, distributions if you want it, or stiffeners. So 1.5 foot. Okay, so we've done the very basic. And just as a side note again, the start file would start basically off at this point. The material and the sections will be defined. So you see here, if we go to our works tab, and we're keeping track now of everything we've been doing up to this point, but they're all in blue. And all that means is that it hasn't been assigned yet. But we have our sections. You can even modify them directly from the workstream if you would just right-click and go to Properties. So now what we're going to do is we're going to start importing from AutoCAD. And what I'm going to do, or actually what I'm going to import, is just the first floor layout, the beams for the first floor. So I go to Import, and then I choose the option AutoCAD, which is DXF format. And I select the file. We will be including in the start files these DXF files, these AutoCAD files. So the first one I'm going to import is just the one it's called Hotel, which is basically the floor layout. And so when you're doing this in AutoCAD, just layer them, create layers. You can have them all in the same DXF file, and from here you just select which layer it is you want to import, and then you would just assign the section. So this is where I'm importing the first floor layout, which means they're the beams, not the columns. And I also make sure that my units are in feet in terms of dimensions. Be careful of that. The default is meters, so if you import this in meters, everything's going to be 3 times what you would expect. And your structure, if you're following the tutorial step by step, it's going to look funky because the ratios are going to be off. So just make sure if you're importing from AutoCAD, you know what units you're importing when you have it here set in the program Midas Gen. So we see here now we have the layout of the first floor, and now the beam has changed from blue to black. That means it's now telling you it's been assigned. So what we're going to do next is extrude the columns for the first floor. So I'm going to go to structure, sorry, I'm going to go to element, and I'm going to go here to extrude. So the program has imported these lines and at the intersections assigned nodes. And so what that also benefits me is that now I can just create these columns by just extruding the nodes in the vertical direction. I just have to give it a distance, and the program will turn them from node to line elements. So here I'm selecting the section, so these are going to be my columns, and I just have to give it a direction. So I'm going to do this negative, and I'm going to tell it that they're 16 feet. And I can just select all my everything, but it's only going to apply it to the nodes. So we see there I've created all these sections just by extruding nodes to lines, but they have the column section assigned to them. So you could also do this manually. You can select some nodes and extrude them on your own and then select different column sections or go back and modify it later. Just as an example, if, for instance, let's say the columns on this end had a different dimension, in Midas Gen, you can just select the column of interest. Here you cannot tell very well that I've selected them because they're the same color red. So actually, to make it a little more clear, what I'm going to do is I'm going to go here to display, and I'm just going to tell the program to assign colors, random colors, to different sections. Okay. So now we see it a little more clear, and we can see what we selected. So let's say these two columns are going to have different sections. I can just select them on the model and then drag and drop a section from the worktree, and the program will automatically update it. So you see there now it's represented by a different color and obviously different dimensions. But that's different ways you can modify very easily files or sections in the program. So I'm just going to undo that and continue on. But just to give you an idea of how you can modify sections so you can have multiple columns, of course, but very easily replacing sections. What we're going to do next is we're going to create the walls. So for this, I will just go here to create elements. And again, this is based on the PDF that I showed you, like the images of the structure. So I already know where the wall elements are going to be located based on those plans. So I'm just going to kind of rotate the model. Bear with me as I'm connecting, basically closing 4 nodes to create a wall element. So the first wall element is, and this is going to be like an L-shaped L right here. So I'm just going to, I've already selected the element type, wall. Here you can choose if you want it to be membrane or plate. The thickness and the material there's only one, but you could select it from here. And like I said, you just have to connect 4 nodes to create a wall element. And so you can just go in order. And so that's part of our structure has walls on this side. And then there's also walls on this side as well. So I'm just going to slide it over and connect. So you can actually skip over sections as well and connect like this. So if you want to rotate the model as such, you can hold down the scroller on the mouse and your control key on the keyboard. And it allows you to rotate the model. If you don't hold down control, but just hold down the scroll button on your mouse, it moves around in the fixed rotation. So if you want to rotate, just include the control command as well in your keyboard, or you can do either or by manually activating it here. It's either a pan dynamic or a rotate dynamic. Or you can see all your views over here. So now we have the basis of the first floor, all the sections defined. What I'm going to do next is define the loads and apply the floor loads to this first floor. And then later I'm going to use a command called building generation that will allow me to generate copies of this story multiple times. And the reason I'm applying the load first is that this way it copies the load with it. All the stories that are generated from it, from this blueprint, will have the load applied as well. And so I don't have to go back and individually apply floor loads to everyone. So let's go to load and define the load cases and then the floor loads. So we're going to go to create static load cases. And I'm going to create 4. So I'm just going to type in here the names and select the type from the drop-down menu. So we have the dead load and then the live load. And then we're going to do 2 earthquake loads in the different directions. So these are static seismic loads, lateral loads. Last month we did a steel structure and we applied static wind loads. In this training we'll do static seismic loads, but you can have a combination of wind and load or whatever it is. We're just, again, getting started with very introductory tutorials, so we're keeping it simple. But as we progress, we'll be also doing more advanced analysis in the future trainings to come. So we'll just have one for the X direction and then the Y direction. But as I mentioned, there are many kinds of load cases you can create. You see here from the menu. We're gonna assign the self-weight to the dead load. So all we gotta tell it from here is the dead load case that gravity or self, is in the negative Z direction. And so we just add it and close it. And then now we're gonna go ahead and assign the floor loads, for which first we have to define them. So you go first to the first tab, which is define the floor loads, and then we assign them. So this is the floor load type. So in this case, you can create multiple cases. You can create some for like the certain areas. I don't know. Supposing that like a building is used for different purposes, you can create different loads types for each one and then assign them to individual floors separately. In this case, we're going to just assign the uniform one and we're just going to call it hotel. It's very important you give it a negative value because we want it to be applied downward as a force. If you use a positive value, the notation in the program will have them going the opposite direction that you're expecting. And so we're just going to do the dead and live load. We give it a name and we just add it. And then you can close this. I mean, this is where you could create multiple scenarios or types and then assign them separately. But here we'll just do one for everything. And then we go back to the same tab and go to assign floor loads. So here we've selected the type. In this case, like I said, we only have one. You can also go directly here and just create additional ones. The distribution type you can select from here. We're going to use the two-way distribution, but you can see that if you select different ones, you can get a small diagram. You could also check our manual to get a better understanding of these distributions and how you can use the angle to select the correct beam that you want it to be distributed over. But in this case, we're fine. So all we have to do is define an area, which means that it has to have a closed area. So as I'm going, I'm just literally selecting the outer corners. Even though there's turns, it doesn't really matter. As long as I end up in the same starting point, we see now that the floor load has been applied. So from here, we can actually generate the first half of the building by making copies. So I'm going to go to Structure, Control Data, building generation. Although you can also just press Control G on your keyboard. And so you see here, we can give it information, very basic information, very easy to understand information. So I'm going to tell it, I want 5 copies, but it doesn't have to be the same column height. So I'm actually going to give it a different height. I'm going to make them a little shorter, each of these 5 floors. You can actually do this multiple times and just select different sections if you want it. But in this case, we're only going to do it the same copies of the same floor. So I just go here to select everything once I added the information, and I go to apply. And so we see now that we have the whole box structure, but that now here in the floor loads we have the 6, so it's been also copied if I wanted to just display it. This is why we applied it first. You don't want to go back and manually have to apply these. So now I'm going to modify the structure a little bit. I'm going to delete some sections. So I'm going to do the first, what we call here the front view, and I'm going to delete select by going like in the other programs like eTabs and such. If you go from right to left, it selects all the sections and the nodes as opposed to left to right, which will only define whatever is directly covered in the box, not just what it crosses. So I'm going to delete these first, just pressing delete on my keyboard. And then I'm going to go to the right view and do the same. So as a guide, I have this wall here. So I'm going to draw a rectangle and capture these beams and columns and just press delete again. So that when I do the 3D view, it's starting to look more like our diagram. Okay. Actually, I was also supposed to capture this. There, that actually looks like our structure now. Okay, so it's a good thing to give it an inspection in 3D, like by rotating the model. So now I'm going to go back to importing from AutoCAD. I'm going to import another section. As we recall, there were 2 DXF files. So I'm going to go back to import AutoCAD DXF. And this time I'm going to import a geometry of the balcony. So I'll go over to browse. So this could be the same AutoCAD file and you just have it under a different layer. In this case, just to show, you can just select a different AutoCAD file only for this particular section. And of course, we want to assign the correct section to it, which is the balcony beam. Now you can give it a specific position relative to where you want it to be. So in this case, because it was all part of the same DXF file, like the whole structure was made originally, I don't mess with the origin point. Everything's gonna line up exactly. So we see here that the beam connects exactly to where I had originally, when I made the AutoCAD file, had it relative to the rest of the structure. So just keep that in mind. Then when you're also making the DXF files, you can move them within the program. It does give you a chance to give it specific coordinates. But if you're just importing from the DXF file and it's all part of the same structure, you just have it layered differently, the program will keep that location information in place. So we have now the balcony segments or elements in place. So we're going to make more copies of only this top floor. In order to do that, we want to reassign the floor load only to this new area. So we go back to load, assign, and I now select only the nodes for this new floor. So we have it there. So now I'm going to make copies of only this top floor. So I'll go back to the same procedure, structure, control data, building generation. And this time they're going to have a different height. They're going to be even shorter per, so we're only going to do 4 copies, but they're only going to be 10 feet high per story. So we add it, and then we select what we want it to be applied to, or which sections we want to copy. So I'm copying the top floor, and I just go to apply. And so now we have our final geometry, or final structure as it's going to be without the piles. So we can proceed now to do some analysis or apply the earthquake static loads, lateral seismic loads, and then run some analysis, some designs, even footings, and then we'll go finally back and apply the piles and the soil springs. So we have our structure. We need to do a few more things before we apply the lateral seismic loads. What we want to do is we wanted the program to create the story data. So we're going back to the same tab where we had the builder generation, but this time it's the one right above it called story. And the program will automatically do this for you. What it's going to do is it's just going to find the height of the nodes, like the planes of the nodes. So it knows now that we have 11 stories, and it knows the location or the height. So we see there's a variation in the height of each as we have been making copies varying that distance. And this is useful for the program. Here you can activate or deactivate the floor diaphragms for each individual floor, but it also makes it seamless when you're applying some of those lateral static loads. The program already knows the height or the distribution to apply to each level of the nodes internally. The other thing we also want to do is just tell it here under structure type that we want to convert the self-weight into masses. So now we go to apply the seismic loads, the lateral static loads, static seismic loads. We go to add, and we're going to apply one for the X direction and one for the Y direction, but they're actually going to be very similar. The way that we distinguish that is within the setting, you give it a scale factor in either direction. So here we will do it first for the load case in the X direction. You see that you can select different load codes, international codes from all over the world, and then you assign other information like the site class. You have to give information about the period. If you click on this button on the side, you'll have this option that can be automated. It'll calculate the period for you if you just select from this range. And then here is where you give it the scale direction. So we're going to do this first for X. So X will be the scale 1 and Y will be 0. Here you give information about accidental eccentricity. And if you want to get a profile of what the load will look like per floor, you can just activate this here. And you could see it by force, by shear, by overturning moment. You get all the information about the elevation. So this is why it's important first to get the story data created in the program so that this is done then seamlessly. So we go to apply, and this has been created, and now we can go back and just do it for Y. And the only thing we would have to change would be the scale factor. Now Y is 1, and we'll inverse the eccentricities. But you can modify it however you like, or customize it however you want. And you can see the symbols there, kind of these static seismic loads. So we basically, for this simple tutorial, we were going to stop here at applying loads, and we'll just go ahead and apply what would be boundary conditions and run the analysis. So firstly, we'll just fix it. As part of supports, we're just going to fix the bottom nodes completely. Later, like I said, we'll go back and apply piles and model the ground as springs. So for now, we just go to boundary, define supports, and I'm going to fix displacement and fix rotation. I'm going to select the from view and draw from left to right a rectangle so that it only selects the nodes. So here when I apply it, I'm only selecting the bottom nodes. You can see that the icons correspond to this support condition, this boundary condition at the bottom. And lastly, we want to specify the load to masses condition. So we would go here to load to mass, and we can give scales for different, so not just self-weight, but the dead load. Let's say it's a scale of 1, and the live load, we can give it a scale of like 0.8 or something. So we're ready to basically run the analysis in this current setup. We can just go here to perform analysis, or you can just press F5, or you can go directly to this tab and press perform analysis. So this is a relatively small structure. There's not a complicated analysis like time history or anything. So it'll be a relatively quick analysis. And so we see here that it's finished running. It gives us a time. Like I said, it's a very small number, very few number of elements. It's not a big structure, so it doesn't take a long time to run. So let's look at some results, or how we can see results in the program. So you would go now to the results tab, and you see here we have all kinds of results. We're going to focus on this end. And so you see they're kind of grouped by type of result. So first let's look at the displacements. So you can select from here displacement contour. You can select the load case. As of now, we only have the starting load cases. Later we'll create the load combinations for the design. So let's say the live load, the deformation in XYZ, and I'm going to activate the legend in the deformation, and I go to apply. So we see here the results we're getting. Of course, this is just deformed, and by a scale you can control. And then the legend, the results are over here. So I can actually modify this in this button right here with the 3 dots. And so instead of, let's say, looking at it exponentially, I just want to see fixed values with 2 decimal points. So we see there that that's how you can modify the legend. So here we're looking at displacements. We can look at other things like the forces or the moments on the beams in the columns. So let's go here to the next option, beam and forces and moments. And so the moments would be the my, the actual forces be fx. So you can just go through these different results that you like. If you want to see them as diagrams, then you would just select the different option, which would be here, beam diagrams. And you would tell it something like, I want it to be solid fill, so it's easier to see. And so you're seeing the same result, but I think for beams and columns, it's much more clear to see it in this format, in the diagrams. So the my is your moments. And then the Fy and Fc are your shear forces, depending on which direction you're looking at. And of course, well, we also have wall elements, so you can also take a look at those results. They're just a different type. So you would go here to wall forces or wall diagrams. You can see them, again, by both methods. So we're looking here at the actual forces and such. So this is just results, but the program can do more than just analysis. It can also do design. So let's move on to that part. We're going to design some columns. We're going to design some footings. that you can define, or you can design anything within the program. So we're going to create first the load combinations. So we see here that we have it for different materials. If we were doing steel design or concrete design, or if we had a combination, you can auto-generate them based on the code that you've selected. The program will make these combinations for you automatically. So let's go to concrete. You select the code. We're going to use ACI 318/14. And the program makes these combinations for you. You can inspect them all, you can modify them directly, or you can add additional ones on your own. So let's also do that for the footing. Okay, so we have the load combinations. Now we can go to the Design tab. And you see here that the program has, depending on what kind of material you're designing, you'll have different menus. So last month we showed steel, this time we're in reinforced concrete. So we're going to select the code and then go to the menu for RC design. I'm going to design some columns. And so what I mean by design within -gen, we're talking about the reinforcement design, the rebar design. The program is going to try to fit the most rebar it needs, based on the load requirements and the load cases within the section you've defined. So for that to happen, first I need the program to have information about my reinforcement on my current column. So first I have to define it. And so I'm here going to column rebar data, and I'm selecting my section. And I'm going to tell it some basic information and distribution about my rebars. So I can see here that as of now I only have 4 rebars. Let's just say there's 6. Or whatever information. You can do like rows of 3, and you can just give whatever information you want to give it based on the size of the bar that you have. So let's say that. And then here we'll do the 4 inches. So we see here we have this distribution of rebar now. So I'm going to go add replace, close. And so before I tell the program to design it, maybe I had a preconception, and for now it's okay. So I want to do a check first, a code check, before I tell it to design it. So to save time, I mean, if we just do code check, it'll do it for all the columns. I'm going to focus, let's just select the columns here for time purposes. So only do a check on these 5 or 6 columns. So I would go here to I select my columns, and I go to concrete code check, and I'm going to select column checking. So a few number of sections, so it's going to do it relatively quickly. Here we have the result for the property, but we can also do by members. So see, we're saying one of the columns in particular is faring worse than the others. And we can even select this option and get a graphic detail report. So we see here our current rebar distribution. We get our PM diagram, which we're outside of. And we're seeing specifically that it's the axial forces and the moment capacity checks that are not good. That's what the NG means, and it's in red. So that's fine. So I can now tell the program, I know that it's not the rebar or the reinforcement isn't good enough, so I can tell the program to design it for me. But I can also specifically tell it certain criteria. So I'll go here to design criteria by rebar. I can tell the program which rebars to consider. Now, you might have different norms that you want or different rebars that you can choose from. So first you want to set the options. You go to Tools, Preferences, and you go here, there's a tab for Design. And so here's where you can specify which rebar options you'll have when you're telling the program to do the design itself. So here it's fine. We have the norms or the codes that we're currently working with, but you could change that. So now I can go back to design and specifically tell the program, I only want you to consider from 3 or 4 rebar sizes when you're making the design of the reinforcement. So I would do that here. As of now, if I ran it, the program would think that I only wanted to consider a rebar of the size number 7. But let's give it a few more options. You can choose up to 5. So let's let the program find what's optimal between these types of rebars. But you can see here, when we were in preferences, this is what would be activating the different columns if you wanted to use rebars of different types. And you could do the same for the other sections. Oh, sorry, so this is for the beam. We would want to do the same for the column. And so now I can go back. I'm still selecting the same column sections, but now I'm going to tell it to do design, column design. So the program, again, by design, it means that it's designing the reinforcement based on the rebar data that I've given it, but the section size itself stays the same. If we wanted to do a section design, which we're going to do for the footing, we would have to link it to our other program, Design Plus, which we're going to do in a second. So I'm just trying to clarify, design within only Metis Gen is reinforcement design, rebar design, unless we're talking about steel. But if we want it to be a full section design, change the size of the section as well, not just the reinforcement, we would connect it to our other program, Design Plus. So here are the results for the reinforcement design. We see now that it's in blue and it's okay. And if we go back to the graphic, there's now a new distribution of rebars. We used to have only 6. Now we see we have a lot more. So it's using different sizes of the rebars, and we see here from all the axial moments, but everything has passed, and we're within our PM curve. So everything looks good now. So our program has found the optimal size, and you can just tell it to do the update of the rebar, and it'll update that information for those sections. You can also get a 3D PM curve if you like. So that would be design within the section. Let's now do footing, and I won't do the reinforcement footing. What I'll do, or not only, but what I'll do actually will be I'll test the code of it, like I'll do a code check, and then I'll connect it to our Design Plus. Design Plus will actually import the loads from this model and the section, the dimensions, but then it will do a design of the section size, not just rebar information. So we just give it a name. From here we select the node. So footings are just nodes. Any node at the base is basically the footing. So let's select one of the, I can activate the node number display. Let's select one that's like under the balcony, so it might have a higher load applied to it. So this one is number 61, and we see it here now appear, but we can see it also there. Kind of maybe the display's a little off in the transmission, but you can leave your cursor over it as well, and we see there the location, and it's node 61. We can give it some information about the load combinations, or you select which node combinations you want, and you can tell it some information about the rebar, and you can do, again, similar to what we had done before, like first a test, a code check. So we're seeing here we're not passing. And so you can go back and give it information about what rebars to consider, and then try to get it to design the reinforcement of it. But suppose that all that fails, but what if you just wanted to get the optimal size for your load? So what we're going to do is we would go to Tools and double click on Design Plus, which will open this other program. And see here, we can select what kind of sections we are going to design. We're going to look at footing, but you can do and link it to walls, basements, beams. You can do other things, staircases. If you're working on steel, you can do bolt connections, web openings and such. So it's pretty handy complement to Midas Gen. So let's do an isolated footing. So this actually would work independently. You don't have to link it to Midas Gen to work. You can actually just do your own loads, and you can give it your own dimensions for different sections. In this case, we're looking at footing, and you can do checks and designs independently. But what we want to do, of course, is bring information over from the model we just created. So we're going to select, in this case, there's more than one gen file open. So the one we're working on right now, just make sure you're connecting to this. It's just select it from the list, connect. And so now the program is going to, based on which node I have selected, it's going to bring that information over. So I'm going to go back here to this window, and I'm going to select the same node, number 61. Sorry. I don't want a section. I want the node because I'm doing footing, so I'm going to let that go. Okay, there. So I have the 61 here selected, which is this footing over here. And so now that number appears here on Design Plus because it's connected. And so I can import, I can press import, and I can now select it from the works tree. And so all the information has been brought over. And so I can first do a check. And again, as we saw in the other program, it's not passing the sole bearing or the shear test and all that. So not only do I want it to design the rebar, but we mentioned we wanted to design the section. I can go here to Options, Preferences, and basically just let the program know that within certain parameters, change the section by design. So I'm allowing it to change the section to different sizes as it sees fit, and if I need it, I can give it a limit, like a maximum of a thickness in this case. So now instead of pressing check, I can just press design, and the section size itself has changed, the distribution of the rebar has changed, and now all the tests pass. So you can use this information and go back to Midas Gen and modify your column dimensions or something and run everything again. But this is pretty handy in that sense that it's not just doing reinforcement, it's also the section itself. And some other nice features of this, we can go to this drawing tab and create the AutoCAD section drawings. So it's a nice complement to the program. Okay, so that's just giving you very simple examples of how you can link the Midas Gen to Design Plus. So let's just go back, and to conclude this, I'm just gonna create some piles now and model the soil as springs. So what I'm gonna do is I'm gonna delete this boundary condition that was basically just fixing the nodes to the ground. I'm gonna put a front view, and I'm gonna go to Element, Extrude, I'm going to select the section pile, and I'm going to do every 10 feet 2 times. So there'll be a node every 2 feet, every 10 feet, but essentially the pile itself will be the pile itself will be the 20 feet total. So what I'm going to do next is I'm just going to select the nodes at the base to extrude it. That was not the right direction. I'm left out a comma here, so I'm going to undo that and add that comma there. So the program has this option where it lets you select the previously selected sections or nodes or elements. So here I just went to this command right here, select previous. And now that I added that comma, the program knows that I'm not talking about the Y direction, but actually the Z direction. So we have our piles in place. And so of course, if we have piles, then we need to model the ground. So we go here to boundary, and we're going to select pile spring supports. So the program has its internal PY curves that you could select from the soil type. And you just have to give it some information like the diameter of your pile, other information you get from lab tests from a geotech engineer about the subgrade reaction, modulus, and such. So here we're just applying information. And so we want to apply these only to the piles. So I could do a side view and try to carefully select the sections that correspond. Or one last trick, I guess, if you will. If you right-click on a corner of this bar, you'll see that we have an option for a second tree menu. So I can go to Works, and specifically from the section list, just right-click that and tell it that I want to select only that section. So here I'm automatically only selecting the piles, so that now I applied the springs only to that. And I would just rerun the analysis. Oh, yes, the program now has picked up that there's additionally 2 more stories, if you will. So you want it to automatically update that information. So now story 1 and 2 are below ground, and story 3 is at the ground level. So now I can just run the analysis again. So it's finished. This time it took longer. We're doing a more complex analysis based on the boundary condition, which is piles and springs. So it took a little bit longer. So now, we can just look at a few results, but from here on out, it's really just the conclusion of the tutorial. You can now select from different load cases, all the combinations that we had to look at particular results. Let's see now, you see the concentration of moments in the piles for the load case of the static, seismic, and the extraction. So that's basically it. If we just go back to the slides, that's the last slide for the steps. So that's basically the conclusion for this particular training. Just as a commentary, in our webpage, which is northamerica.midasuser.com, you can go to training and review previous course, not just this topic, but other previous topics. As a side note, also, you can check upcoming courses. So we do have a very interesting soil structure interaction case study by a user in Brazil, where he imports the structure to our geotech software and designs the foundation in soft soil. So you're welcome to register and participate. That would be April 4th, so in about 2 weeks.